There are two objectives in this section. First, solve trigonometric integrals involving powers of sine and cosine. Solve trigonometric integrals involving powers of secant and tangent. In this section, you will study techniques for evaluating integrals of the form integrate sine power to the m of x times cosine power to the n of x with respect to x. And for the second case, integrate the secant to the power m of x times the tangent power to the n of x with respect to x, where either m or n is a positive integer. To find antiderivative for these forms, try to break them into combinations of trigonometric integrals to which you can apply the power rule. For example, you can evaluate the integral of sine power to the 5 x times cos x with respect to x with the power rule by letting u equal to sine x. Then du dx equal to cos x. And we move dx to the right side, we have du equal to cos x dx. And we have integrate the sine power to the 5 x cos x with respect to x is equal to integrate the u power to the 5 with respect to u. So we use power rule, and we have u power to the 6 over 6 plus c. And we change back the u, we have sine power to the 6 x over 6 plus c. In this case, we can use change of variable method because the cosine, the order of the cosine is just only the 1. It's the first order. Okay, but for this case, if there are the power, the order for the both sine and cosine, so we should break up this form into which you can apply the power rule. And we use the following identities. For example, we use the Pythagorean identity, and we use the half angle identity for sine square x, and we use the half angle identity for cos square x. There are some guidelines to solve the first objective. For the first, when the power of the sine is odd. Here, the sine function has an odd order, and positive, save one sine factor and convert the remaining factors to cosine. So look at this step. We save one sine factor. So we break the order into 2k plus 1. So which is sine power to the 2k of x. And one more is sine x. And then convert the remaining factor to cosine. So we convert the sine square x to 1 minus cos square x. For the second, when the power of the cosine is odd and positive. So the order of cosine is odd. So we break into the 2k plus 1. Save one cosine factor. So this is the meaning of the cos power to the 2k of x times the cos x. And we convert the remaining factors to sine. So we convert the cos square x to 1 minus sine square x using the Pythagorean identity. When the powers of the both sine and cosine are even and non-negative, make repeated use of the identities. So we can use half angle to convert the integrand to odd powers of the cosine. Then proceed as in the second guideline. Look at the first example. We have the integral of sine cube of x times the cos power to the 4 of x with respect to x. Because you expect to use the power rule with u equal to cos x, save one sine factor to form du and convert the remaining sine factors to cosine. So we can rewrite. First, we know that the order of sine function is odd function. So we break it into the sine square x times sine x. And we convert the sine square x into 1 minus cos square x. And we expand in. We have cos power 4x minus cos power to the 6x times sine x with respect to x. So we can expand again. So this is a guideline of the second objective, where we have a form of secant times tangent. First, when the power of the secant is even and positive. So the order of the secant is even and positive, save a secant square factor and convert the remaining factors to tangent. Then expand and integrate. So we will have secant square x power to the k minus 1. And we still have one more secant square x. Because when we expand in with this, we will get back the secant power to the 2k of x. Then for this part, secant square x we convert into the 1 minus tangent square x using the Pythagorean identity. Second, when the power of the tangent is odd and positive, save a secant tangent factor and convert the remaining factors to secants. Then expand and integrate. Now look at this one. If the order of the tangent is odd, so we can break it into the 2k plus 1. So we will have tangent square x power to the k and tangent x, one more tangent x here. And we can break the secant power to the m of x to the secant power to the m minus 1 of x times secant x. Then we will get this form. For the third scenario, let's say when there are no secant factors and the power of the tangent is even and positive, convert a tangent square factor to a secant square factor. Then expand and repeat if necessary. Now we try to break the tangent power to the n to the tangent to the power n minus 2 and tangent power square. And then we convert the tangent square x here into the secant square x minus 1. When the integral is of the form, just integrate the secant power to the m of x with respect to x, where m is odd and positive. Use integration by parts. The last one, when none of the first 4 guidelines applies, try converting to sine and cosine. Look at this example. So because you expect to use the power rule with u equal to secant x, save a factor of secant x tangent x to form du and convert the remaining tangent factors to secants. Now we will write our integrand. Move the radical secant x to out, so we have the secant x power to the negative half and we break the secant x. We use the second rule on page 11. Second rule, we break the secant x power to the negative half into secant x power to the m minus 1 times secant x. Refer to the second rule. And for the tangent qx, we break into the tangent square x times tangent x. So we convert the tangent square x into secant square x minus 1. And then we expand in the secant x power to the negative 3 over 2 into this factor. After we expanded in, we can use change of variable method, because we can let the inner function as secant x, and the derivative of the secant x is secant x tangent x. And then we perform the change of variable. Lastly, we have the answer. Let me show you how to get the first term. For this part, we can let u equal to secant x. So du dx will equal to secant x tangent x. So dx will equal to du over secant x tangent x. Now we perform the change of variable. We have integrate the u power to the half and secant x tangent x. Because this factor should expand into the first term and also for the second term. So for the first term, we have u power to the half times secant x tangent x, and with respect to x, so where the dx is equal to du over secant x tangent x. We can simplify this secant x and tangent x. So lastly, we just need to integrate the u power to the half with respect to u using the power rule. And we have u power to the 3 over 2 over 3 over 2. And we can simplify so that we have 2 over 3 and the u is a secant x. So it's a secant So it's a secant power to the 3 over 2. So we obtain